to 2 minus y, 2 minus y, 2 minus y, xy dx dy. Hence, evaluate the integral. So what is the given question? Okay. So I will send the material to you, solved problems, don't worry. Just listen carefully. Now solution. So what is the given problem? Integral 0 to 1, integral root over y to 2 minus y xy dx dy. So in this problem, the limits are variable limits. That's why this is x. So other variable is y. Okay. Now first draw the region, then we will change the order of integration. Okay. What is the region? So here x equals to, first x equals to root y. Nothing but x square equals to y. Nothing but a parabola. And also other curve is x equals to 2 minus y is nothing but x plus y equals to 2. If you divide with 2, okay, this is nothing but x by 2 plus y by 2 equals to 1. Okay. So first identify the region. Okay, I will write here. First, x is root over y is nothing but parabola. This is x square equals to y. If it is completed, don't worry, I again listen the problem. Now, other one is x by 2 plus y by 2 equals to 1 is a straight line. So here first point of intersection is here, another point of intersection is here. So this line is y equals to, or x equals to, then no problem, y equals to 2 minus x. So what is the region here? Lower curve along x-axis, parabola to straight line. X equals to y is nothing but parabola, and this is line. So this is the total region. And also find out the points of intersection. For finding the points of intersection, here y, here also y. Y equals to x square, and other y is 2 minus x. If you equate these two, x square equals to 2 minus x, x square plus x minus 2 equals to 0. If you find the roots of the equation, so minus 2 comma 1. Whenever x is minus 2, y becomes 4. Whenever x is 1, so y becomes 1. So the points of intersections are minus 2 comma 4, and other one is 1 comma 1. Okay. So in this diagram, first point of intersection, this point of intersection is 1 comma 1. Other point is minus 2 comma 4. So in this region, y limits 0 to 1. That's why 0 to 1. Y limits 0 to 1 along y-axis up to this region. Okay. I will show you in detail in bigger diagram. This is parabola. This is line. So the total region, this part, the shaded region, the total region is divided into two parts. One is R1, second one is R2. Because if you find the limits along y-axis, that is in this direction, upward direction, here curved region, upper region, this is straight line. So that's why we will divide into two regions. This curve is y equals to x square, and this is totally different y equals to 2 minus x. So if you have upper curves, two different curves, now separate into two different regions. So first we will evaluate the integral for R1 region and also R2 region. Okay. I will explain a similar problem again, don't worry. One more problem also, right? 1 minute. Okay. Now coming to integral. So in the given integral is y equals to 0 to 1. Okay, we'll write again. Y equals to 0 to 1. X equals to, I will send the notes, don't worry. I will send the written notes. 2 minus y. Listen carefully, just listen carefully. And xy dx dy. Xy dx dy. Now this is the procedure for writing the problem in the examination. So write the diagram here and rough work right side, then write again. By change of order of integration, change of order of integration, what is the methodology? This integral is same as first what about the y limits, then what about the x limits? Along with integrand is same, xy dx dy. Okay. So what about the y limits over the region R1 and also same procedure over the region R2. So two different regions, that's why this problem is most important for examination point of view over the region R2. So we are divided the total region R into two different parts, R1 and R2. Okay. For R1 region, lower curve along x-axis, okay, I will take another color just for better understanding. From lower curve to upper curve. Lower curve is here y is 0, upper curve is y equals to x square for R1 region. Y equals to 0 to x square. Okay. Now along x-axis, here point of intersection is 1, 1. Here x is 1, x equals to 1. Here x equals to 0. So limit 0 to 1. X is 0 to 1. Okay, fine. For R2 region, again the lower curve is this one to this one. Lower curve is y equals to 0. Fine. 0. Upper curve is a straight line because two different lines, 2 minus x. Now x limits, okay. Now here the point of intersection is 2, 0. This point of intersection, because the x intercept is 2, 0, 2. So x limits now from this one to this one. X limits 1 to 2. 1 to 2. Okay. Now integrate for the over the region R1 and also over the region R2 separately. Okay. X is 0 to 1. Now integrate with respect to y. X is constant, y square by 2, 0 to x square dx. Here, integral x is 1 to 2, same, integrand is same, y square by 2, 0 to 2 minus x dx. Okay. Now integrate. X is 0 to 1. 1 by 2 is constant. X into x power 4. X into x power 4 dx. Here, x is 1 to 2. 1 by 2 is constant and x into 2 minus x whole square. 2 minus x whole square dx. Okay, integrate. So for integrating, first simplify this one, I will write here. X into rough work 2 minus x whole square equals to x into 4 plus x square minus 4x. That is x cube minus 4x square plus 4x. Okay. After simplifying, x is 0 to 1, x power 5 dx plus 1 by 2 into integral 1 to 2 after simplifying x cube minus 4x square plus 4x dx. Okay, now integrate and simplify. Very easy question. 1 by 2, x power 6 by 6, 0 to 1, and also 1 by 2, x power 4 minus 4x cube by 3 plus 4x square by 2. So 1 to 2. Now substitute the limits. 1 by 2 into 1 by 6 minus 0 plus 1 by 2 into 2 power 4 minus 4 into 2 cube by 3 plus 2 into 2 square, okay, minus lower limit 1 minus 4 by 3 plus 2. Okay, now simplify it, you will get the required solution. So entirely this problem depends on this identification of this region and changing into the coordinates. Okay, in the similar way, I will explain one more question to you. Same similar question, okay, but in different direction. Another question, listen carefully. Listen carefully. Change the order of integration. Change the order of integration. Change the order of integration in integral 0 to 1, integral x square to 2 minus x, same similar problem, but in different direction. And hence evaluate it. Now, what is the question? If you observe the previous problem, same problem, 0 to 1, root over y to 2 minus y, here in place of y, here x. Similar problem. Okay. Now, first identify the region. So, the given problem is integral 0 to 1, x square to 2 minus x. So, this is in terms of y, this is in terms of x. Okay, identify the region. Y equals to x square is a parabola. Okay, fine. And y equals to 2 minus x is nothing but x plus y equals to 2, dividing with 2. X intercept is 1, x intercept is 2, y intercept is 1, right? 2, 2. Okay. Now diagram. Listen carefully. Same procedure. First, y equals to x square. Okay, parabola. Y equals to x square or x square equals to y. There's no problem. Y equals to x square. And upper curve is a straight line. X plus y equals to 2. Same diagram. Okay. Same diagram. But region is totally different. So already you know about the points of intersection. So y equals to 2 minus x, y equals to x square. If you simply equate these two, x square equals to 2 minus x, already known. Same like our previous problem. There is no change here. X equals to minus 2 comma 1. So when x is minus 2, y becomes 4 and 1. So this is the first endpoint of intersection 1, 1. And this is another point of intersection minus 2 comma 4. So in this problem, lower curve is observe, lower curve is parabola to straight line. So this one. And x limits 0 to 1. So in the previous problem, this is the region, required region. Now region is totally different. Okay. Okay. So don't worry. This is our region. Okay, highlighted region is our region. Okay. Now again, our region, upper curve. Now observe, for change of order of integration along x-axis, now what about along y-axis? So now change the order of integration. Here integration with respect to y, then integration with respect to x. By change of order of integration, first we want the limits of, in terms of x along x-axis. If you observe along x-axis, here straight line and this is parabola. So again divide into two regions. Upper region is R1, lower region is R2. Again it is divided into two parts. That's why this is also most important question. So the total region is divided into two regions, R1 and R2. R1 and R2, that's why what is the limit? By change of order of integration, change of order of integration, now this integral, the given integral, I will call it as I. I will call it as I equals to integral, okay, first limits y, here h. What about x limits over R1 region? Integrand is same, integration is very simple, don't worry. If you understand the concept, then it is very simple. X y dx over the region R2. So over the region R1, so upper part, along x-axis, now along x-axis, now just to observe, write a line. So this is the lower starting point, this is ending point. Starting point is x is 0, ending point is from this one x equals to root pi. Oh, sorry. Line, this line, what is the line here? Line equation is x equals to 2 minus y. Sorry, 2 minus y. And y limits, y starting from here y equals to 1, starting limit. Here upper limit is y equals to 2. So 1 to 2. In the similar way, for the bottom part, start along x-axis, lower curve is 0 and upper curve is root y. Fine. Y limits here 0 to this point, 0 to this point only, along this one, 0 to 1. So now integrate separately and add them, you will get the required solution. Okay. First, y is 1 to 2. Integrate with respect to x, y is constant, x square by 2, 0 to 2 minus y dy. Integral y is 0 to 1, y into integral x is x square by 2, x limit 0 to root y dy. Now substitute the limits. Y is 1 to 2, y 1 by 2 is constant term, 2 minus y whole square dy plus 1 by 2 into integral 0 to 1, y is 0 to 1. So y root y whole square is y dy. Okay. In the previous problem, like our previous problem referred, y into 2 minus y whole square expansion, this one expansion, then expansion y into 4 plus y square minus 4y. So after simplifying, y cube minus 4y square plus 4y. So integrate integral 1 to 2 y cube minus 4y square plus 4y dy plus 1 by 2 into integral 0 to 1 y limits 0 to 1 y square dy. Now integrate 1 by 2 y power 4 by 4 minus 4y cube by 3 plus 4y square by 2. 1 to 2 limits plus 1 by 2 into y cube by 3, 0 to 1. Now substitute the limits. First, upper limit to 2 power 4 by 4 minus 4 into 2 cube by 3 plus 2 into 2 square. Now lower limit, put y equals to 1, 1 by 4 minus 4 by 3 plus 2. Here for the second term, 1 by 3 minus 0. Okay. Now simplify it, you will get the required solution. But it is very easy, don't worry. Okay, I will explain one more question, then I will close this method. Now listen carefully. Up to this clear, any doubt from student side? Okay. If you have any doubts, then ask me. I will explain again. Okay. After completion of the next problem, we will discuss about the last topic in our syllabus, that is triple integrals. Now coming to another question, change the order of integration. Order of integration and evaluate integral 0 to a integral x by a to root over x by a x square plus y square dx dy. Integrand is very simple, don't worry, integration is very simple. If you understand the concept, then it is very simple. Okay. What is the given problem? First, 0 to a, x by a to root over x by a, okay, then no problem, x square plus y square dx dy. So this is in terms of y, this is in terms of x, because of variable limits in terms of x. What is the lower curve? Just for understanding, y equals to x by a is nothing but a straight line. Now second upper curve, y equals to root over x by a is nothing but y square equals to x by a. It is a parabola. It is a parabola. Okay. Now, if you draw the curve, very easy, draw the curve, x-axis, y-axis. Lower curve y equals to x by a is a straight line, passing through origin. Look like y equals to mx. Look like y equals to mx. Now, another curve, y square equals to 4ax. So, it is a parabola, this one. Now, what is the region? Along y-axis, so straight line to parabola, this one. Straight line to parabola, this is y square equals to x by a. Straight line to this parabola, and the x limits 0 to a. Here x is 0, 0. Now up to the point of intersection. What is the point of intersection? Here point of intersection is observed. Here x by a, this curve x by a, this is also x by a. From this one y equals to y square. So y square minus y equals to 0. Y into y minus 1 equals to 0. So y is 0 and 1. Whenever y is 0, x becomes 0. Okay, fine. Y equals to 1, sorry, y equals to 1, x becomes a. So the point of intersection is one point of intersection is 0, 0. Other point of intersection is a comma 1. So this is the total shaded region. By change of order of integration, now this integral I equals to, I will call it as I equals to, now change the limits. First y here. What about the x limits along x-axis? Along x-axis, I will write another color. From along x-axis, draw a line. Starting curve is a parabola. From this one, x equals to a into y square up to x value ay. Now y limits along y-axis. Here y is 0 and y equals to 1. At this point, y equals to 1. Upper limit is 0 to 1. 0 to 1 x square plus y square dx dy. Now integrate with respect to x, then integrate with respect to y. Y 0, 1. Now x square integration is x cubed by 3 plus x into y square by y square. Limits a y square to a y dy. Now substitute the limits. Y is 0 to 1. A y whole cube by 3 upper limit a y square whole cube by 3 for second term, a y into y square minus a y square into y square dy. Very easy integration. Here a cube by 3 first term, y cube integration is y power 4 by 4. Here a cube by 3 is common term. Y power 6 integration is y power 7 by 7. Here a y into y square is y cube, integration is y power 4 by 4. Here y square into y square y power 4, integration is y power 5 by 5. Limit 0 to 1. Now put y equals to 1, a cube by 12 minus a cube by 21, a by 4 minus a by 5. Okay. If you simplify, you will get the final value. Okay, whatever it may be, just simplify it. So simplify the a cube quotients and coefficients of a. Very simple. Now, another very, very important concept. Now we will discuss about the next method up to this change of order of integration. So in this unit, we will discuss about double integrals. First topic is double integrals. Double integrals in Cartesian coordinates, nothing but in terms of x, y. Now, second topic is double integrals in polar coordinates, nothing but r comma theta. And third topic is changing into polar coordinates, And fourth topic is change of order of integration. Change of order of integration. And fifth topic is triple integrals. Triple integrals, but triple integrals is very small topic according to our syllabus. Okay, so first four concepts are completed. Very easy. Now coming to triple integrals. What is triple integral? Triple integrals. So in our syllabus, very simple concept. If the limits are given, directly find out the integration. Nothing but integral. Suppose x equals to a to b. Just for understanding, y equals to some function of x to some function of z. And third one, z limits some function of x, y to some function of x comma y. Some integrand, okay, some integrand is f of x, y, z, dx, dy, dz. Suppose if the given problem is look like this problem, first integrate with respect to z, then integrate with respect to y, then integrate with respect to x. If you integrate with respect to y, if you integrate with respect to y, with respect to z, other two variables are constant. X and y are treated as constant. If you integrate with respect to x, sorry, with respect to y, other variable x is treated as constant and last is constant. So like our double integrals. Okay, now what about the problems? Very easy, don't worry. First question. I will explain with simple problem. Evaluate. Listen carefully. So in the class tomorrow, we will discuss about another concept. Okay, like fifth unit. Integral 0 to 1. Integral 0 to 1. Integral square root of x square plus y square to y, x, y, z, dz, dy, dx. This is the problem. Listen carefully. First identify the variables. Then integrate. Okay. I will write again. Listen carefully. 0 to 1 constant limit. Again 0 to 1 constant limit. Happy. But here root over x square plus y square to y. So our limits in terms of x comma y, that's why this is z. Okay. Here both are constant limits. Choose any one, then y or x, then no problem. I will take x. I will take y. Suppose if it is variable limit, now choose the other variable. X, y, z, dz, dy, dx. First integrate with respect to z, then integrate with respect to y, then integrate with respect to z. This is the order. So in this problem, first x is 0 to 1. Y is also 0 to 1. Now x and y both are constants. Integral z is z square by 2. Okay. Root over x square plus y square to y dx dy. Now substitute the limits like our previous double integral. Very simple. 1 by 2 is constant term. X is 0 to 1. Y is 0 to 1. X, y into y square minus x square minus y square dx dy. If you substitute the upper limit, y square. If you substitute the lower limit, root over x square plus y square whole square. So root and square cancel, you will get this one. Here y square cancel. Now simplify 1 by 2. X is 0 to 1, y is 0 to 1, minus x cube y dx dy or dy dx. Now integrate with respect to y. X is 0 to 1, minus x cube, y square by 2, limit 0 to 1 dx. If you substitute the limit, minus 1 by 2, x is 0 to 1, x cube. If you substitute the limit y equals to 1, so you will get 1 by 2 dx. Now, minus 1 by 4, x cube integration is x power 4 by 4, 0 to 1. So, minus 16 is the answer. If you substitute the limit, you will get minus 1 by 16. Very easy. Try to understand. Very simple question. First, identify the limits, order of integration, then integrate one by one. Easily, you can get the solution. Okay. Now, coming to another question. Second question. Evaluate integral 0 to 1, integral y square to 1, integral 0 to 1 minus x dz dx dy. Indirectly given the order, okay, but should not follow the given order. Logically follow the order. 0 to 1, y square to 1, 0 to 1 minus x dz dx dy. Okay, now clearly observe, this is in terms of y. Whenever in terms of y, so this is right. Whenever this is y, now this is y. Okay, here x in terms of x, not x, already not y. So this is z. Now other variable is x. Just try to understand the logic behind this concept. So in terms of y, limit, second limit, so next limit is y. Here in terms of x, so maybe x or maybe y, y is already completed, that maybe y or z, so that is z. Okay, other variable is x. Now coming to the integration part. Y is 0 to 1, x is y square to 1, integral z. Here x is constant, integral dz is z, limit 0 to 1 minus x dx dy. Okay, now substitute the limits. Y is 0 to 1, x is y square to 1, x into 1 minus x dx dy. Okay, if you simplify, y is 0 to 1, y is y square to 1, x minus x square dx dy. Now integrate with respect to y, then integrate with respect to x. Y. First with respect to x, then integrate with respect to y. X integration is x square by 2. X square integration is x cube by 3. Y square to 1 dy. Okay. Now substitute the limits. Y is 0 to 1. X, put x equals to 1, 1 by 2, 1 by 3, upper limit. Now lower limit y square. y power 4 by 2, y power 6 by 3 dy. Now substitute the upper limit, then lower limit. Now integration with respect to y. So this is 1 by 6. If you simplify, you will get 1 by 6. 1 by 6 into y. Here, y power 4 integration is y power 5 by 5. Y power 6 integration is y power 7 by 7. Limit 0 to 1. So 1 by 6 minus 1 by 10 plus 1 by 21. Now simplify it, you will get the required solution. Very easy. If you understand the order of integration, then it is very easy. Now coming to the third question. Third question. Evaluate. Integral 1 to e, integral 1 to e, integral 1 to log y, integral 1 to e power x, log z, dz, dx, dy. Now observe the problem, very easy, but here little bit knowledge is required for integral log z. Okay, I will explain, don't worry. 1 to e, 1 to log y, 1 to e power x. So okay, now second limit log z, inside log z, dz, dx, dy. So this is in terms of y, that's why this is y. Okay, this is in terms of x, so this is x. Other variable is z, bigger one. First integrate with respect to z, then integrate with respect to x, then integrate with respect to y. This is the order. Now what about integral log z? Okay, go to rough work. If you know the formula, then it is okay. Otherwise, integral log z or log x, integral log x dx. So for finding the integral log x, we will use 1 into log x, integral uv formula, uv. What is integral uv? U into integral v minus integral u dash into integral v. Here u is log x, v is 1. So using this formula, what is the integral value? First u is log x, integral v, integral of 1 is x, okay, minus integral, derivative of u is 1 by x, integral 1 is x dx, okay, x log x, here both are cancelled, integral dx is x. So finally, what is the integral log x dx? Formula x log x minus x. If you know this formula, then it is very easy. Okay, coming to our question. Here y is 1 to e, x is 1 to log y. Okay, fine. Log z, integral log z is z log z minus z. So z limits 1 to a power x. So any doubt? Any doubt?
No, sir.
No, sir.
This is x, okay.
No, sir.
Oh, okay, then okay. Dx dy. Now substitute the limits. Very easy. Very easy. I will write here. y is 1 to e, x is 1 to log y. First put z equals to e power x. This is e power x. Log of e power x, log and e are opposite functions. You will get x minus e power x. Okay, fine. If you put z equals to e power x. If you put z equals to 1, z equals to 1, log z is 1. So minus or minus plus 1. Okay. Dx, dy. Now integrate with respect to x. Very easy. Y is 1 to e. Now again, what is integral x e power x? Again using UV formula or use the shortcut trick. I will explain the shortcut trick. X, first term is u, second term is u. Now find out the derivative 1, x derivative 1, second term e power x, integration e power x, again integration e power x. Now use arrow marks plus minus. Multiply these two, integral value x e power x minus e power x. So x e power x minus e power x, here minus e power x plus x. So x limits 1 to log y dy. Okay, fine. Y is 1 to e, put x equals to log y. So log y, e power log y is y minus 2 times of e power log y is y 2 times plus log y. Okay. Put x equals to 1, x equals to 1. Now x equals to 1, what happened? E minus e plus 1 dy. Okay, simplify it. Y is 1 to e, y log y minus 2y plus log y. Here e cancel plus e minus 1 dy. Okay, again integrate using UV formula. This is u, this is v. U, this is v. Okay, log y. Integral y is y square by 2 minus integral. Derivative of u log y is 1 by y. Integral is y square by 2 dy minus 2y square by 2. And also log y integral value is already known. Y log y minus y plus ey minus y, limits 1 to e. Okay. Okay. Sorry. Okay. After that, after finding the limit integral, we will apply the limit. Then no problem. Log y square by 2. Here y cancel y square by 2. Then we will apply the limit. Y log y minus y 2y ey 1 to e. Now first substitute the limit y equals to e. Log e is 1, e square by 2 minus e square by 4 minus e square plus e minus 2e plus e square. If you put y equals to 1, this is 0, minus 1 by 4 minus 1, this is 0, minus 2 plus e. Just simplify it, you will get the required solution. If there is any numerical error, just cross check it. Okay, we will get the solution. Now this is the procedure for finding triple integral. Now another problem. Very easy. If you know the order, then it is very easy. Okay. We will discuss one more question. Evaluate very simple question. I will take up another simple question. Integral minus c to c, integral minus b to b, integral minus a to a, x square plus y square plus z square dx dy dz. Now listen carefully. Okay, I will explain this problem. Here, if you observe, all are constant limits. Now apply this order. Use this order. So first this is x, this is y, this is z. Z is minus c to c. Y is minus b to b. And x is minus a to a. And one more very important point, x square plus y square plus z square, each and every term is an even function. Now observe, suppose x square. If you replace x by minus x by minus x, you will get the same function. If you replace y by minus y, you will get the same function. If you replace z by minus z, you will get the same function. So this entire term is even function. So by using the properties of integral, integral minus a to a, f of x dx is 2 times of integral 0 to a, f of x dx. So using this property, here, 2 times, 2 times, 2 times, simply we can write it as 8 times of integral z is 0 to c, y is 0 to b, x is 0 to a. Very easy problem. So no need to take the lower limit, simply write it as z 2 times dx, dy, dz. Now integrate with respect to x, very easy. Z is 0 to c, y is 0 to b, x cubed by 3, xy square plus xz square, 0 to a, dy, dz. Now 8 times of z is 0 to c, y is 0 to b, a cubed by 3 plus ay square plus az square, dy, dz. Now integrate with respect to y, then integrate with respect to z. Very simple. Z is 0 to c. Now integrate with respect to y. A cubed by 3y plus ay cubed by 3 plus ayz square, 0 to b, dz. Now substitute the limit. Z is 0 to c, a cube b by 3 plus a b cube by 3 plus a b z square dz. Now integrate with respect to z 8 times. This is both are same, 2 a cube b by 3 z, a b z cube by 3, limit 0 to c. Now if you substitute the limit, I will write here 8 times 2a cube, oh, sorry, both are different. 8 a cube b by 3z plus a b cube by 3z plus a b z cube by 3, sorry, 0 to c. Now substitute the limit. A cube b c by 3, a b cube c by 3 plus a b c cube by 3. So for after simplification, very simple, 8 by 3 times of a b c into a square plus b square plus c square. Very easy, but not difficult. Very simple problem. All are constant limits. Okay. Now, fifth question. Fifth question. 1, 2, 3, 4. Oh, okay. Fifth question. Integral 0 to log 2. Okay. 0 to x, integral 0 to x plus log y e power x plus y plus z dz dx dy. So in this problem, very easy question, but it will take more time for simplification. First, constant limits 0 to log 2. Second, 0 to x. So that's why this is x. Okay. Now, in terms of 0 to x plus log y, so whenever this is x and y, this is y, already x is completed. Now, third variable is z. E power x plus y plus z can be written as e power x into e power y into e power z. Dz, dx, dy. Now, how to integrate? How to integrate? Okay. Now, integral x is 0 to log 2. Y is 0 to x. With respect to z, e power x into e power y into e power z integration is e power z. 0 to x plus log y. X plus log y dy dx. Okay, fine. Okay. Integral x is 0 to log 2. Y is 0 to x. E power x into e power y. Now substitute the limits. E power x plus log y minus e power 0 is 1. Dy dx. Okay. Now with respect to y. X is 0 to log 2. Okay. I will simplify, then integrate. 0 to x. E power x into. Now observe. E power x into e power log y is nothing but y. So inside e power y, e power x minus e power y. Dy dx. Here observe. E power x plus log y can be written as e power x into e power log y. E and log opposite functions. That's why you will get y into e power x. Okay, y into e power x. And multiplying with e power y, here e power y, and also here e power y. Now, x is 0 to log 2. Now integration with respect to x. Okay. Now here also e power x is constant. Y into e power y. Already we we derived the integral formula. X e power x equals to x e power x minus e power x. Using this formula, x e power x minus e power x. So y e power y minus e power y. Okay. Now e power y integration is e power y 0 to x. Now substitute the limits, very easy. Just, but it will take more time for calculation part. e power x. Put y equals to e power x. E power x into x e power x minus e power x minus e power x. Okay, minus. If you put y equals to 0, okay, this is first term. I will write one more time. E power x into, if you put y equals to 0, 0, minus 1, minus 1, okay, dx. Just substitute the limits x and e power x. Okay, now simplification, little bit bigger one, bigger term. Okay, whatever it may be, we will simplify it. E power x into x e power 2x minus e power 2x minus e power x, here plus e power x plus 1 dx. Here this term cancel. Now simplification. Integral 0 to log 2 x e power 3x minus e power 3x plus e power x. Okay. Just I will check the terms, whether it is correct or wrong. X e power x, x e power 3x minus e power 3x plus e power x. Very good. Fine. Correct. No mistake up to this one. Okay. Now again, integral uv. uv or shortcut trick. X derivative 1 e power 3x. Integration is e power 3x by 3. Again, integration is e power 3x by 3. So multiply these two, signs plus or minus. Now, if you multiply these two, x e power 3x by 3 minus e power 3x by 9, e power 3x by 3 plus e power x. Now 0 to log 2. If you put x equals to log 2, here e power, I will write here, e power 3 log 2 can be written as e power log 2 cube, that is 8. Okay, so 8 by 3. Now this is also 8 by 9, 8 by 3 plus 2. If you put x equals to 0, this term is 0, minus 1 by 9, minus 1 by 3, plus 1. Emma, are you understanding? Any doubts? Any doubt from student side?
No, sir.
Sir, please once again explain.
Okay, okay. Now we are entering to the last question of triple integral. Then we will discuss about your doubts only. Okay?
Sir,
Tell me. Chapama.
please once again explain this sum, sir.
Okay, okay, very good, fine. Listen. Listen carefully. So in this problem, integral 0 to log 2, 0 to x, 0 to x plus log y. This is most important question. E power x plus y plus z dz dx dy. Okay. So I will write the same term. Here, I will write here. This is in terms of x. So next integral becomes x. This is in terms of x and y. That's why this is z, other variable z. So here x is completed, z is completed. Now coming to third variable y. Now, here, first integrate with respect to z, then integrate with respect to y, then integrate with respect to z. This is the order of integration. Now e power x plus y plus z can be written as e power x into a power y into a power z. Okay, fine. E power z integral value is e power z. Lower limit is 0, upper limit is x e power y. Okay, remaining two things are same. So if you observe this integral, this substitution, e power upper limit in place of z, x log y, e power x log y is e power x and e power log y. E and log both are opposite functions. That's why you will get y into e power x. So y into this term, y into which one? Y into e power x and e power y. If you multiply both the terms, e power y and e power y. Okay. So remaining terms are same. So after simplifying e power x, same time. Here, this one. This is e power x. Here e power x. These two terms. Y, e power y. Okay. Okay. And second term is e power y. Okay. Now integrate with respect to y. After integrating, again we are using now observe. Here e power y integration is e power y. Integral y e power y is this one. Okay, e power x is e power x. This term is integral of this term is this one. Okay. Now put y equals to x. So e power x, here x, a power x, minus e power x, minus e power x. Now put y equals to 0, e power x. Here y is 0, 0. E power 0 is 1. Here e power 0 is 1. So after simplifying, multiplying with e power x and x e power x, e power 3x, e power x and e power x is e power 2x, minus e power x, minus or minus plus e power x, minus or minus plus 1. Okay, both are opposite signs cancel. Now multiply with any doubts? Emma? Someone raise their hand. Ask me. Okay. E power x into x e power 2x is x e power 3x. E power x into e power 2x is e power 3x. E power x into 1 is e power x. Again, we are using x into e power 3x into using integral formula. This is u term. This is v term. U term is x, v term is e power 3x. Now derivatives here, integrations. E power x, e power 3x integration is e power 3x by 3, e power 3x by 9. X derivative is minus 1. So alternatively minus and plus, multiply these two, x e power 3x by 3, multiply these two, e power 3x by 9. Okay. E power 3x integration is e power 3x by 3, e power x integration is e power x. Now upper limit log 2, put x equals to log 2. So log 2 whole cube, nothing but e power 3 log 2 is nothing but e power log. If it goes to the power 2 cube, nothing but 8. This is 8 by 3. This is 8 by 9, 8 by 3. Here, e power log 2 is 2. Okay, minus lower limit. If you put x is 0, 0. This is minus 1 by 9, minus 1 by 3, plus 1. Very easy. Just try to practice all these questions. I will share to your groups. Okay, and also recording video. Along with recording video, for missing students, they can watch again, or if you want, watch again my explanation. Now coming to, I will share the video also, don't worry. I will share the video. If you want, observe again and again. Okay. Now last question, today's last question on triple integrals. Integral 0 to pi by 2, integral 0 to a sine theta, integral 0 to a square, a square minus r square by a or dz dr d theta. Okay, I will check the question whether it is correct or not. First, I will check the question. If there is any calculation error, then 0 to pi by 2, 0 to a sin theta, 0 to a square minus r square by a. Very good. Correct. Okay. Listen carefully. This is also most important question for examination point of view. You may get the same question in mid-examination or maybe in final examination, you can't say. Now, listen. 0 to pi by 2, listen carefully. 0 to a sin theta, 0 to a square minus r square by a or dz dr d theta. So here the limits are variable. Here variables, first variable is r, other variable is theta, other variable is z. If the given integral in these three coordinates r, theta, z, call it as cylindrical coordinates. Nothing but cylindrical coordinates. Our problem in cylindrical coordinates, then how to find the integral? But just name is cylindrical coordinates, procedure is same. Here in terms of theta, that's why this is theta. Here in terms of r, other than r and theta, that's why this is z. Other than r and theta. Theta both are complete. Theta is completed and r is completed. Now coming to the third variable z. Now this is r. Okay. But very easy. Theta is 0 to pi by 2. R is 0 to a sin theta. Now integrate with respect to z. Integral dz is z. 0 to a square minus r square by a. Now remaining two variables are dr d theta. Now substitute the limits. But not difficult, very easy. 0 to pi by 2. R is 0 to a sin theta. R into a square minus r square by a dr d theta. Okay, don't worry, very easy. Now integrate with respect to r. Very, listen carefully. Simple integration. If you put a square minus r square equals to t minus 2r dr equals to dt. Here we have r dr equals to dt by minus 2. Now what about this integral without limits? R dr is dt by minus 2. And this is t. Okay, constant, we will come in the constant. Minus 1 by 2 t square by 2. What is t? T is a square minus r square whole square. A square minus r square whole square. Now common minus 1 by 4 a. Theta is 0 to pi by 2. After integrating with respect to r, you will get a square minus r square whole square. Okay. Limits r limit 0 to a sin theta. A sin theta d theta. Okay. Now substitute the limits. Minus 1 by 4a. If you put r equals to a sin theta, a square minus a square sin square theta whole square. Now, if you put r equals to 0, a square whole square is a power 4 d theta. Now integral 0 to pi by 2. Theta is 0 to pi by 2. Okay. Now simplification. Minus 1 by 4a theta is 0 to pi by 2. Here a square, if you common a square under whole square, a power 4. Here a power 4, here also a power 4, I will write it as a power 4. Now remaining time is 1 minute. Sorry, small disturbance. Sin square theta whole square minus 1. 1 minus sin square theta is cos square theta minus a cube by 4. Theta is 0 to pi by 2. Cos square theta, that is cos power 4 theta minus 1 d theta. Okay, I will simplify cos power 4 theta. Rough work. Cos power 4 theta is cos square theta whole square. Cos square theta can be written as 1 plus cos 2 theta by 2 whole square. That is 1 by 4 times of 1 plus cos square 2 theta plus 2 cos theta. 2 cos 2 theta. Now again, cos square 2 theta can be written as 1 plus cos 4 theta by 2 plus 2 cos 2 theta. Okay. In place of cos power 4 theta, we can write it as, okay, wait 1 minute. Okay. Now replacing cos power 4 theta by minus a cube by 4. Theta is 0 to pi by 2. If you know the simple formula which is in our intermediate, then it is very easy. So 1 by 4. Okay, I will write one more 1 by 4 here. 3 by 2. 1 plus 1 by 2 is 3 by 2. Plus, no, wait. Don't write here, write here. 1 by 4. 3 by 2 plus cos 4 theta by 2 plus 2 cos 2 theta minus 1 d theta. Now integrate minus a cube by 4, 1 by 4 into 3 theta by 2 plus sine 4 theta by 8, 4 theta by 8 plus 2 sine 2 theta by 2 minus theta 0 to pi by 2. Now substitute the limits. Very easy, don't worry. 3 pi by 16. The second term is 0, third term is 0, minus pi by 2. If you put theta is 0, all terms are zeros. Now simplify it. Minus a cube by 4 into 3 pi by 16 minus pi by 2. Just simplify it. You will get the required solution. Okay. So after this, we discussed about several, total 6 triple integral problems. If you have any doubts, I will clarify it. Otherwise, today I will stop here. Tomorrow we will discuss about unit number 5. Okay, I will conduct separately for ECEC and CSIT because for most engagement. maybe our limit is 100. So tomorrow we will conduct separate classes on unit number 5. So introduction class and the first classes are most important for examination point of view. We have very less time. That's why we are conducting through online. If you have any doubts, then ask me. Otherwise, we will close it today. Any doubts from student side? Okay, I understand. Suppose if you have any doubt, I will share the video to you, okay, through YouTube, but data is a huge data. That's why I will upload to YouTube, then I will send the YouTube link. That it is very easy. And also I will share the entire notes. Just copy all the notes in our notebook. Just practice it. All are most important for mid exams and also final exams. You may get similar questions or same questions in the examinations. So don't leave it. Each and every question is most important for examination point of view. Okay. So meet again tomorrow morning, 9 o'clock for one branch, other branch, other time. Okay. We will discuss the timings with other faculty. Okay. Tomorrow we will conduct separate classes for CSIT and ACSC on unit number 5. Because our strength is 130, but limited here limit is only 100. So inform to others. But first topic is very easy, definite question in the examination. In unit number 5, again we have two parts. One is vector differentiation, other one is vector integration. Vector differentiation and vector integration. Vector differentiation is very easy. So you will get A question from vector differentiation, B question from vector integration. So that's why most important and also very easy. First part is very easy and also limited concept. We have only 3 topics in part A and also 3 theorems in part B. Total 6 concepts in our syllabus. Okay, very easy. Don't worry. Okay, I will explain each and every one. Okay, today I will stop here. If you have any doubts, I will clarify your doubts on multiple integrals. Anything? Doubt? Shall I close it? Respond.
Yes, sir.
Okay, I will close it. If you have any doubts, then I will clarify it. Otherwise, I will stop here. Okay, meet again in tomorrow's class. Bye.
Bye, sir.
Bye.
Bye, sir.
Bye.
Bye, sir.
Bye. Have a nice day.